Good morning. Welcome to the first video session for Food Technology 1 FOT150S. My name is Vusim Shaisa and today I'm going to be talking to you about the Pearson square method. What is the Pearson square method? The Pearson square method is a method that is used worldwide and in industry to calculate the ratios of components that can be mixed together to form a homogeneous mixture. These components can be proteins, amino acids, vitamins, minerals, or sugar concentrations. In the practical that you are going to do next week, you will be required to calculate a known concentration of sugar and salt solutions. Before you do that, you will have to use the Pearson square method. Once you have prepared your salt or sugar solutions, you will then use a refractometer, which is the tool that you see here, in order to determine whether the solution that we have prepared according to the Pearson square method is exactly as the Pearson square method informs us. Before we proceed, there are certain things that we need to understand. One is the definition of Brix. Brix is defined as the concentration of sugar expressed as grams sucrose per 100 grams of solution at 20 degrees. Ladies and gentlemen, therefore, Brix is expressed on a mass basis. In other words, if you have a 35 degree Brix solution, this implies that we have a concentration of 35 grams of sucrose per 100 grams of solution. Brix is measured on a scale from 0 to 100 using a refractometer. Therefore, if you have 0 degree Brix, that means there is no sugar. Therefore, you have 100% water. On the other hand, if you have 100 degree Brix, it means you have got 100 grams of sucrose per 100 gram. Thus, in this case, you have solid sugar with no water. So, before then, we can use the Pearson square. Now we understand what Brix means. The Pearson square, you use squares in order to calculate the required ratios. In this case, we have two components: water, which is 0 degree Brix, and sugar, which is 100 degree Brix. The number that you see here in the middle is called the requirement or a specification. This is what you would like to achieve. This is what you are working towards, or this is what you would like to have at the end of the day. If I were to look at this calculation, this then means that at the end of the day, this person wants to have a solution which is 35 degree Brix. The principle of this method is that the specification or requirement, which is this middle number, should always be a middle value or an intermediate value between what you have on your right hand side, which is water, which is 0 degrees, and 100 degrees. So 35 falls in the middle, right? If you were to have, for example, 135 degree Brix as your specification, the Pearson method or the Pearson square method will not be applicable, because that number of the requirement or the specification is not an intermediate. So that is rule number 1. Number 2, when we have the Pearson square method, we subtract the values of what we know to the specification diagonally. In this case, you'll have 0 minus 35 or 100 minus 35. So if we say 100 minus 35, we get 65 water and 35 sugar. So obviously, as students of mathematics, you'll be thinking, hey, what's happening? Are we not supposed to get a negative 35? If minus 0 minus 35, 0 minus 35, you're supposed to get negative 35. The principle of this method is that we disregard any negative numbers that are generated in this calculation. So in this case, we have a positive 35. So let me explain what we then have on the left hand side. If you look here, I started with water and then I have sugar. So same applies on my right hand side. I still have water, and also here on my right hand side at the bottom I have sugar. So these two components, please make sure that they always go across. You just put them across, as we say in maths. What you do on the right, you must have also on the left. So secondly, please note that what we have on the left hand side is water, and we have units which is degree bricks. Same applies with the specification. However, when you come to this side, we do not have units, we call these parts. So in this case, you will have 65 parts of water mixed with 65 parts of sugar. That will give us a total of a solution that has got 100 parts. So if you want to prepare a solution, a sugar solution that is 35 degree bricks, you need 65 parts of water into 35 parts of sugar. In other words, you can say you need 65 grams of water to be mixed with 35 grams of sugar to give you a solution that is overall 100 grams. But this is always parts, right? So let's look at the first example. If you are asked to prepare a 25% sugar solution, this is how you may proceed. So one thing that you need to note is that this is a sugar solution. So you are going to dissolve sugar crystals in water. So you have water here, which is 0 degree bricks, and we have sugar, which is 100 degree bricks. As I've said, we subtract diagonally. If you subtract 0 to 25, you get 25, and if you subtract 100 to 25, you're supposed to get 75. Alright, so you have 75 parts of water and 25 parts of sugar. This then gives you a total of 100 parts. Right? So what are the ingredients that you need to weigh now? So if you are in the lab and you are requested to prepare this solution, you will therefore weigh water 75 grams and sugar 25 grams. Then you mix this solution completely, and afterwards you observe your results using a refractometer to check what is the concentration of the sugar solution. At this point, I'd also like to point out that the sugar here can also be anything else. The water can also be anything else, right? But in this particular case, where you are told it's a sugar solution or it's a sugar syrup, it has to be water and sugar. Let's look at a second example. You are requested to prepare a 50-degree Brix sugar syrup to be used in a fruit juice formulation. So again, we are told we are dealing with a sugar syrup. So basically it's a mixture of water and sugar. But this time around, we want the concentration to be 50-degree Brix. So how do we do that? We have water, which is always 0-degree Brix, and we have sugar, which is 100-degree Brix. So if we want to prepare a 50-degree Brix, we will then say 0 minus 50 and 50 minus 100 minus 50. Then we've got 50-50. So 50 parts of water into 50 parts of sugar. So in other words, you have a total solution which is 100 parts. Therefore, what are the ingredients that are required in this case? We require 50 grams of water into 50 grams of sugar. Ladies and gentlemen, you may also be asked to express this in different units. It can either be kilograms, can either be grams, milligrams, as long as you have your parts correctly calculated. The mass or the unit of measure can be changed to anything that you desire, depending on the scale at which you are working at. So let's look at the third example. We want to prepare a sugar concentration of 25-degree Brix from two separate solutions that gave the following Brix readings. Solution A gave 15.5-degree Brix and solution B gave 37.5-degree Brix. What we are asked to do is to express your final quantities in kilograms, right? So what are you going to have? You're going to have solution A, which is 15.5, and solution B, 37.5. If you subtract diagonal, you'll have 37.5 minus or subtract 25, and then you'd have 15.5 or 15.5 minus 25, right? So at the end of the day, you have solution A 12.5 parts and solution B 9.5 parts. Then the overall parts that you have for your solution is 22 parts. So what are the quantities or ingredients required? So you require to have solution A 12.5 kilograms into 9.5 kilograms of water. That, if you combine it together, will give you a total quantity of 22 kilograms. So this is how the Pearson square method works. Let's look at another example. A tank containing 476 kilograms of tomato sauce has a Brix reading of 42-degree Brix. The specification calls for an average of 35-degree Brix. Recommend how you will adjust this batch of tomato sauce. So if you see, the food technologist goes and analyze the tank. The tank of containing tomato sauce is 476 kilograms. So this is tomato sauce, right? So what is it that we know? we know that the tomato sauce is 42-degree Brix as given here, which is higher than the required amount of 35. So in other words, we have more sugar than what is required. And I would like to point out that in these cases where you have more sugar, it may mean that the company is losing money by producing extra sugar or by using extra sugar in the tomato sauce. But now if you have a tomato sauce with sugar already added, you cannot take the sugar out just like that. So what you can do to remedy the situation is to add water. Other words, you're basically diluting the tomato sauce or tomato paste. That's why here we have water, which is 0-degree Brix, and the tomato sauce, which is 42-degree Brix. If you subtract diagonally 0 minus 35, you will get 35, and 42 minus 35, you will get 7 parts. Then 7 parts plus 35 parts, then you have 42 parts in total. So because in this case we know that there is tomato sauce and there is water, so how much water should we then add into this tomato sauce in order to bring it back to 35 degrees Brix? So what we will do is the ingredients required. In this case we require water. So how much water do we require? We require 7 parts divided by the total parts multiplied by 476 kilograms, which is the amount that is already there, what you have, and that will require you to add 79.3 kilograms of water. So this is basically the principle of the Pearson square method. So it squares because if you close this up here until here, you will find squares, right? So in literature you will find different ways in which the Pearson square is explained, but the principle is still the same. The principle behind the Pearson square is the same. So what is your task? Your task is to complete the pre-lab exercises on Blackboard. And these exercises will serve as an entry ticket for you to the pilot plant. So in the pilot plant, you should already go there having done calculations. You should know how the calculations work and how does Pearson square work in principle. So what you will do when you get into the lab, you'll be given either sugar, salt, and food products. For the sugar part, you will have to first calculate how much you require for a given sugar solution. How much sugar you require and how much water to prepare that concentration. Once you have prepared your concentration, now you have to then analyze that sugar concentration, that sugar solution using a refractometer. So we'll have both sugar solutions, salt solutions, and we will also have various food products that we will practically measure their sugar concentration using a refractometer. You will also then be required to prepare a juice from a given specification. Then you'll also have to do calculations then. So ladies and gentlemen, that's it about Pearson square method. Thank you for your kind attention. Should you have any questions or queries, do not hesitate to drop me an email. Thank you very much.